Imagine there's no heaven. No, I'm not about to break into song, nor am I about to preach to you. And what I really want you to imagine is a world where we no longer rely on fossil fuels. No more petrol for cars, no more diesel for trucks, no more jet fuel for planes. In the words of John Lennon, it's easy if you try. And it's also easy to imagine the benefits. Everyone is well aware of climate change and where we are heading with our current emissions. Everyone except for maybe Trump and his supporters. But push that horrible image out of your mind, go back to that perfect world where we've severed our reliance on fossil fuels. It's all good and well to imagine, but how do we actually achieve this? Well, that's where my research comes in. My research focuses on the synthesis of large polycyclic aromatic hydrocarbons. Now, that was quite a mouthful. What I'm talking about is an area of chemistry where the molecules resemble chicken wire, like you see up in the centre. Now, these hexagons that make up my chicken wire molecules are really, really tiny, however. If you make a circle with your thumb and forefinger, that is about the size of the hexagon in regular chicken wire. The hexagons that make up my molecules are 500 million times smaller than that. Now, that's an incredibly hard scale to grasp, so let's flip that on its head. And if you take that same ring, expand it by that same scale, 500 million, you would have a huge ring able to encompass the Earth side by side twice. Now, these molecules can have a whole heap of interesting properties, all dependent on how many of those hexagons there are and how they're arranged. This is something that, as an organic chemist, I control through bottom-up synthesis. I take the smaller building blocks, I combine them together to make the larger molecules that I am interested in. By now you're probably wondering what on earth all these hexagons and chicken wire molecules have to do with energy and fossil fuel. Well, the molecules that I'm synthesizing in particular have the potential to double the efficiency of solar cells. Now, solar cells work by absorbing a photon of light as energy from the sun and converting that into an electron. Now, regular solar cells absorb one photon per electron they give out. The molecules I'm making in my PhD undergo a special exciting process known as singlet fission, turning one photon into 2 electrons, doubling the efficiency. Just imagine a world where we no longer rely on fossil fuels. With this bright idea, it's easy if you try.